This demo will explain to you in a few very simple steps how recursion works. The recursion is different to what we've done up to now, since normally functions have been called from main, and functions might have been called from other functions as well. But with recursion, a function calls itself. Now, given that, just try to forget it for a second and look at the functional definition of factorial, which we will use to explain recursion. But forget that recursion is a function that calls itself. Just look at this definition. This definition says the faculty of n, in its definition, contains the faculty. So this is a self-referencing definition. It says in order to calculate the faculty, we use faculty. In order to calculate the factorial of a number n, we use the factorial of the number n minus 1. So we use the definition in itself. It's a self-referencing definition. Be that as it may, the definition says there's either one of two values. The factorial of n is either equal to 1 or is equal to this thing based on what the value of n is. So we're going to implement that in C, and in very simple terms, it looks something like this. We declare our function to return an integer, factorial, and to get an integer in that we're going to call n. And inside here, all we're going to do is we're going to say if n is equal to 1, this function should return, so the result of this function should be 1, else this function should return something else. And this something else we get from the definition is n times the faculty of n minus 1. N times the faculty of n minus 1. Alright, so that's our factorial definition. Just try to forget for the minute that factorial calls itself. The definition does as well, so let's look at whether C can handle it. So let's just create a main as well. Inside this main, we're going to have a variable called x, some lines of code, and then somewhere we will say x is equal to the factorial of, let's make it 3 as an example, and then lines of code, lines of code, lines of code, until we have our return here. And remember, the return says take something and pass it out to whoever called it, and what you're passing back is an integer. Okay, so let's take the steps through here. The program cursor is the thing that tells you where the program is at, what part of the program is executed or being executed. So I'll pretend that this pen is marking the program cursor. So first of all, it starts with main, and then it goes get some memory and give it a name and call it x. Does a line of code, line of code, line of code, gets to this point. So what happens here? At this point, what happens is that this value here, 3, is taken because the function factorial is called with an argument 3. This value 3 is taken and it's pasted into n. So n for this factorial function is equal to 3 now. Then it calls the factorial function, and the program cursor goes, whoops, I'm jumping out of main. I first have to do this function which was called. Then I'll come back, set the value of x, and continue with the rest of the program. So it's calling factorial, so it has to complete factorial, come back, and then complete the rest. Set the value of x and complete the rest of the program. So the value of n is equal to 3 now. Program cursor is here, and it says if 3 is equal to 1, which is false, so it's not going to do this. It's going to jump here, and it's going to do this here. This says return the following. Return n is equal to 2, we said. I'm just going to write it down here. N is equal to 2, just so we remember. And it returns 2 times the faculty of, I beg your pardon, n is equal to 3. return 3 times the faculty of 3 minus 1, which is 2. So before it can return, it needs to perform this function, because we're telling it to perform a function. So it does this function. And now I want you to pretend something. Let's pretend it's calling another function. Let's pretend it's not calling itself. Let's pretend that there's another function called factorial, and it looks exactly the same. So I'm repeating, this is just pretend. That's not really what happens, but it will help you understand what's going on. So let's pretend it's calling another function called factorial, which is identical in every way to the other factorial. It is the same factorial, but we're just writing it out again to help us understand the program flow. If n is equal to 1, return 1, else return n times faculty of n minus 1. So you can see this is exactly the same program. There's nothing different. It's exactly the same function as this, same name, same everything. I'm just writing it out twice to help us understand the program flow. So what's happening here now is we reach this point, we see we have to calculate 3 times faculty of n minus 1. So this is 2. So when this function faculty is called, the value 2 is taken and put into n here. It calls the, I've called it faculty, sorry, factorial, calls the factorial function, goes here, and this is the factorial function. So let's pretend it's not calling itself, let's pretend it's calling another instance of itself. And that's really what happens. It calls another instance of this function. The same as you would when I tell you to calculate that in your brain, you'll just say, okay, do this again. And that's exactly what happens here. So do this again from here. So the value 2, 3 minus 1, 2 is taken and put in here. So n is equal to 2. So what happens now is it says, let's go through the motions. Is n equal to 2? No, it's not. So I go to the else condition, return 2 times faculty of 1. So now I have to calculate the faculty of 1. So instead of doing any funny stuff in my head, let's just pretend there's another instance of factorial. And again, I've called it faculty. Beg your pardon. Int factorial int n. If n is equal to 1, return 1, else return n times factorial of n minus 1. And that needs to start and it needs to end. Okay, so this is the one that will be called now. So this value here, which is n minus 1 is equal to 1, that is taken and copied, pasted into this n. So a new variable is generated in memory, and then this function is called with that variable equal to 1. So all of these are remembered because they're in separate functions for all intents and purposes. This still exists somewhere. This still exists. This here called that. This here called this. So we have, in essence, in memory, there are 3 variables. 1 is equal to 1, 1 is equal to 2, 1 is equal to 3. They're all called n within their own scopes. Okay, and what happens now is it says if n is equal to 1, yes it is, so that's true. So this is going to return 1. And this is where I need you to focus quickly. What happens now is this function started, the program cursor went down here, call factorial, so it jumped here, went down, called factorial, it's here, and it sees it needs to return 1. So when it returns 1, it takes that value, and then it's that integer that's referred there. This 1 is put back here. So instead of this factorial called, this 1 is put in here. This is a 1. So this whole thing is replaced by a 1. So this function is now complete. It jumps back into this who called it. That 1 is multiplied by 2 and then returned. So 2 times 1 is 1, as is 2, and that 2 is then returned, so this function terminates as well. So that jumps out, and that 2 is sent here. That result of 2 is sent here, and it replaces this factorial n-1 call. This whole thing turns into a 2. So then 3 times 2 is calculated, which is 6, and that is also returned then. So this factorial function terminates. It takes that 6 and it puts it here, and that 6 is then put into x. Alright, so that's what happens. So the result x is the factorial of 3. So if I had 4, it would have had an additional instance of the function factorial. If I had 5, yet another, etc., etc. So I want to quickly show you the code for that as well, and maybe do a few printouts so that we can see what's going on. So all I have here is I have my main integer x factorial 3, and here I'm just printing out from main. I've just put these words here to print out that it's coming from main. The result is 6, and inside factorial I have my definition for factorial. If n is equal to 1, do this, else return this. So it looks exactly the same as what you've seen now, and you can see it returns with the result is equal to 6. If I do 4, it does the result is equal to 24. Alright, so that's nothing strange. You should know that. What I want to do now is, every time that I call the function, I want to print out factorial called with n is equal to %d, and this is going to be n. Okay, and then I want to also print out what is returned. So I'm just going to do something. Please don't get confused. I'm just going to say, make a new variable int, call it result, and here I just say res is equal to 1, and I say res is equal to that, and I just return. That's doing exactly the same thing. Return res. It's doing exactly the same thing. I'm just moving it out of the if so that I can print out the result. That's all I'm doing. So here I'm now going to print out printf returning with, and then the result, %d res and what I also need to do is I just need to put in new line. So new line there, new line here, and a new line here. So what's going to happen is this is going to call the function factorial. That 3 will be put into n, and it'll do exactly what I've explained what happens here. So what we expect to see, and this is also important to understand, we expect to see here it prints out factorial called with 3. Gets to this point here, before it returns in my code, it's going to call factorial again, and that means I will see a printout factorial called with n is equal to 2. Before it can return, it needs to calculate the factorial of n is equal to 1. So I'll see another printout factorial called with n is equal to 1. And then that gets to this point and it returns 1. When it returns 1, it's going to print out returning 1. Jumps back here, and then it'll print out returns 2, etc. So let me quickly show you what happens. So factorial is called with 3. To calculate the factorial of 3, it needs to calculate the factorial of 2. So it calls factorial with 2. In order to calculate the factorial of 2, it calls the factorial of 1, because it needs to when it wants to calculate the factorial of 2. Now, in the function that calculates the factorial of 1, it can return, because our rule says if n is equal to 1, the result is 1. Otherwise, you have to calculate further. So now it got to this point when n was equal to 1, it returns with a 1. That pops back from here, and then it returns with 2. So that's the 2 that is sent back here into that there, and then returning with the result 6 is where it multiplies that 2 with that 3 and sends it back here and returns with a result of 6. So I think that should help you understand recursion. The difficult part, and you can do this at home, and I'll put the code on web studies as well, is if you apply exactly the same logic, if you apply it to the Fibonacci series. So if you do it to Fibonacci, what you will see is that it's not just a simple linear thing anymore. It's going to be this tree idea, and the output looks a bit different. I'm just going to show it to you quickly. I think it was here somewhere. There we go. So this was my Fibonacci, and in Fibonacci it's just slightly different. It says if it's 0 or 1, then return that 0 or 1, else calculate the Fibonacci, and Fibonacci is defined as that. Just look at the slide quickly. Fibonacci is defined as 0 or a 1 or that. So that's all that this function does. And then if you do the printout, it looks a bit different. I'll quickly talk you through it if I can get the logic this time of night. There we go. So what happens is, first of all, it says calculate the Fibonacci of 5. And then, in order to do that, it needs to calculate the Fibonacci of 4 and 3. In order to calculate the Fibonacci of 4, it needs to calculate the Fibonacci of 3 and 2. In order to calculate the Fibonacci of 3, you can see that 3 relates to that 3 there. It needs to calculate that of 2 of 1, and then this 2 relates to that 2 there. So in order to calculate the Fibonacci of 5, it needs to do all of these first. Then it does that, and the last one that was called was the Fibonacci of 1 and 0. So first of all, 1 returns with a 1, the 0 returns with a 0, and then it works its way back. And then it returns everything back. So let's just quickly look at this. So the Fibonacci of 0 returns 0, Fibonacci of 1 returns 1, Fibonacci of 1 and 2 returns the 1 here, and that's the way it continues all the way up until it reaches the Fibonacci of 5. So I just want to go down here. You can see the this 2 here relates to that 2 there. So all of those relate to the 3. They spawn from the 3 if you want. And then this 2 is when all of this have been calculated, put into that Fibonacci. That's what happens here. And then this 2 relates to that 2 there. So if 3 and 2 have been calculated, then it can move on and do the rest. And the rest is, again, the same process. And I'll just show you what I mean when I say that spawn. This is essentially what happens. And you can follow that logic on your own.